of mesh analysis. But here, if you look at this circuit, here we have 42 voltage source provided, 10 volt voltage source provided, 6 ohm, 3 ohm, 4 ohm, and we have a node right here. And from this, as I look at this, it seems nodal analysis better method to use than mesh analysis, because we are going to have less equation. If we find out what's the current going through this loop, I can solve for everything, right? But if we use mesh analysis, we are going to have two equations. So once you do some nodal analysis and mesh analysis, you will realize which equation is better. But here, for example, I'm gonna use both of them and solve this one, so you can see like how both of them works. Whenever we talk about nodal analysis, we talking about KCL, Kirchhoff's current law. Whenever we are talking about mesh analysis, we are talking about Kirchhoff's voltage law. Now let's solve this same circuit using nodal analysis first, and then we use mesh analysis and solve them and see if we are getting the same answer. Okay, so let's apply KVL. Let's call this node V1. This is the V1 voltage right here. And whenever we have voltage voltage source provided, and if the plus is up and minus is bottom, it means the voltage above the plus is going to be positive 42. So this voltage right here is positive 42. And if you have minus on top, plus in the bottom, this is going to be a negative voltage right here, negative 10. Okay, that's the only thing you have to know. And after that, we can name this current as I1, and we can assume any direction, because if you assume it wrong, we are going to get a negative answer. So we are always going to get the right answer. So I1, and then I can assume this going here, I2, and then I3. Okay. So if I apply KCL at V1, KCL at V1, we know that KCL is summation of all the current is equal to 0, or sum of current in is equal to sum of current out. Let's use sum of current in is equal to sum of current out. What are the current that's entering this node? I1 is entering, and I2 and I3 are exiting. So I2, I3 is exiting. Now write the currents in terms of voltage, because we don't know any currents here. We have no idea what currents are. So we can solve for voltage and find out the current. And we only have one unknown variable when we put voltage, because we have no most of the voltage, only this voltage unknown. We can even name this as V, because we only have one, so we can just name this as V. Let's say this is okay. I1, what's the equation for the I1? You can see the current flowing this direction, a current flow from higher potential to the lower potential. So 42 minus V divided by the resistance in between. 42 minus V divided by the resistance in between, that's 6. And then I2 in this directions, V minus 0, because the bottom part always referral is this connected to the ground voltage, so that's 0. So this is going to be V minus 0 divided by the resistance in between, that's V divided by 3. And then we have I3 flowing this direction, V minus 10, this is 10 voltage right here, divided by 4. V minus 10 divided by 4. Okay, let's solve for the voltage here. So what value, if I multiply everything, I can get rid of all the denominators. You can think of 12 will work. So if I multiply everything by 12, this is going to be 2 on the top. 2 times 42 minus V, and then that is equivalent to, this is going to be 4V, and this is going to be 3 times V minus 10, that's plus 10. Okay, let's simplify. 2 times 42, that is 84, and then minus 2V, 4V plus 3V plus 30. Okay, let's bring the V to the one side and numbers to the other side. I'm gonna bring all the V to this side and this number to this side. So 84 minus 30 is equal to 4V plus 3V plus 2V. 4V plus 3V plus 2V. So we are getting 74. Is it 74? No, 54. 54. 4 plus 3 is 7. 7 plus 2, 9. 9V. Therefore, V is equal to 54 divided by 9. That is 6. So we are getting 6 voltage. V is equal to 6 voltage. If we have V, we can solve for all the currents. If you want to find I1, you have to just plug it in this equation. That is 42 minus 6 divided by 6. That is what? 36 divided by 6. 6 ampere. I2. What's the value? I2 is V divided by 3. 6 divided by 3, that's 2 ampere. And I3 is what? V minus 10 divided by 4, that is equal to V plus 10 divided by 4. 6 plus 10, that is 16 divided by 4, that is 4 ampere. Okay, these are the answer I'm getting. Now what I'm going to do is I note this one separately and I'm going to erase all the things, because now we are going to, this is using nodal analysis. That's how we can solve the voltage and currents using nodal analysis. Now I'm going to use mesh analysis to solve the same problem. That's going to be a little bit different method. So I note these currents to verify after I solve the mesh analysis. Okay. So this is I1, that is 6 ampere. And I2 we got 2 ampere. I3 we got, this one is 4 ampere. Okay, so I have noted these 3 currents, and the voltage also you can note if you want, that is 6 voltage. Okay, so we found all these things using nodal analysis. Now let's use mesh analysis. I'm going to erase everything. Okay, so if I'm using mesh analysis, what I do is, now I worry about voltages. Let me get rid of these things. Or let's keep it as it is. Let's say this I1, I2 and I3. Okay. Okay, now I want to do this one with mesh analysis. In mesh analysis, what we do is we pick up a current direction. Like for example, you can assume clockwise. This is the one I do. Like I assume everything clockwise and then solve for it. So it doesn't matter. Like you can assume counterclockwise or clockwise. It's up to you, but it's better to keep one thing. Like if you keep the same direction all the time, it's going to be easy for you. So here I assume clockwise, and then I name this current as I1, and I assume clockwise here as well, name the current as I2. Then I have to apply KVL in each loop. KVL says that addition of all the voltages in a closed loop is equal to 0. So if I apply KVL at loop 1, let's call this one loop 1. Loop number 1, loop number 2. So KVL at loop 1. So KVL says addition of summation of voltage in a loop is equal to 0. So let's look at the voltages. If I1 going from negative to positive, that's going to be a negative voltage. So we are going to have 42, negative 42 voltage. And if the current is passing through a resistor, the current must flow from higher potential to the lower potential. So this should be plus and this one should be minus. So we're gonna have the current, we're gonna have the volts. Okay, V is equal to what? V is equal to I times R. This is Ohm's law. So if we express this voltage here in terms of current and resistance, this is going to be I1 times R1. Let's say this R1, or you can just directly plug the 6 ohm. So here we can say this is plus 6 times I1. And what else we have? We have this one. So since the current flowing from here to here, this is plus, this is minus. So this is going to be 3 times I1. But you have to look at the current going in the other direction. Here, if you see in the same resistance, there's another current going in the opposite direction. That's I2. So we have to put a minus I2 right here. Okay, and that's equal to 0. This is my equation number 1. I can simplify, expand and simplify. This is minus 42 plus 6i plus 3i and then minus 3i2. That's equal to 0. So if I add the like terms, 6i plus 3i, that's 9i minus 3i2. And if I bring the number to the other side, that's equal to 42. This is my equation number 1. When I apply KVL at loop number 1, now I'm going to apply KVL at loop 2. KVL at loop 2. This is our loop 2. We assume the direction to be clockwise. So, okay, let's look at this. Here we have this one 3. For this 3, if the I2 pass through this, we are going to have a new plus and minus right here. So we are going to have 3, according to Ohm's law, current times resistance. Resistance is 3. 3 times current passing through that is I2. But when we do that for this is plus and minus, and this one is coming in the opposite direction. So this is going to be a negative current. So minus I1. And then here this is going to be plus minus, and then 4 times I2 plus 4 times I2. And when it comes to here, it's going from minus to plus. So we're going to have a negative, and then the voltage value here we have here is 10 voltage. So it's going to be 10. Okay. So these are the two equations. Now let's simplify, expand and simplify. So this the whole thing is equal to 0. Let's expand and simplify. This is 3i2 minus 3i1 plus 4i2 minus 10. That is equal to 0. Let's add the like terms. 3i2 plus 4i2, that is 7i2. 7i2 minus 3i1, that's equal to 10. Okay, so this is my second equation. 7i2 minus 3i1 is equal to 10. And here I have 9i1 minus 3i2 is equal to 42. Now what you can do is you can do elimination to get rid of any of these. Like if I multiply this one by, you have to make something equal. So here we have 7i2, right? We have 7i2 minus 3i1 equal 10. It seems like if I multiply this one by 3 and make the I1 to be a negative 9i1, I can add them and get rid of this I1. So I can solve for I2. So let's multiply this one by 3. If I multiply this equation by 3, the new equation is going to be 3 times 7, that is 21i2. And then 3 times negative 3i1, that's 9i1. And then 3 times 10, that's 30. And I bring this equation, that is, let's put the like terms together. So this is negative 3i2 here, and then positive 9i1 here, and that is equal to 42. And if I add these two together, I add these two together, we know these two are going to cancel. This is going to become 18i2, and this is going to become 72. Okay, so I2 is going to become 18 times 4 is 72. So this is going to be 4 ampere. Okay, so I2 is 4 ampere. Okay, so if I2 is 4 ampere, what is I1? I can find that using one of these equations. Let's pick up a simplest one. Let's use this one. 7 I1. Let's rewrite this one in terms of I1 first. So it will be easier to solve. This is 7 I2 actually. 7 I2 minus 10 is equal to 3 I1. So 3 I1 is equal to 7 I2 minus 10. And instead of I2, I plug this one. So 7 times 4 minus 10. 7 times 4 is 28, minus 10 is 18. 18 divided by 3, that is 6 ampere. So I1 is 6 ampere. Okay. So I1 is 6 ampere, mean the current through this one is 6 ampere. And I2 is 4 ampere, mean current through this 4 ohm resistor is 4 ampere. But okay, I1 is 6 ampere, I2 is 4 ampere. If I take this one as I3, okay, if I take this current as I3, if I assume it's going down, then I1 minus I2, I1 is 6 minus 4, that's 2 ampere. So we are getting the exact same currents. We are getting 6, 4, 2, right? So you are getting the same current, and you can solve for the voltage as well. Since we have the current, we can use the Kirchhoff's current law, or you can use, Ohm's law actually. Yeah, let's use this for this one. Like, we know that, let's say this is I1. So we know I1, if we create an equation for I1, we know that I1 is equal to 42 minus the voltage here divided by the resistance 6. And we know the I1 value, that's 6 ampere. 6 times 6, that's 36. 36 is equal to 42 minus V. Therefore, V is equal to 42 minus 36. That is equal to 6. That's the exact same voltage we got here. So you can see this one is like more equation, more stuff. But if you apply nodal analysis for the circuit, it's going to be simpler. Both of them give the same answer, but this one little bit more step. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.